All right, so we're doing 6.2. This is on the unit circle. And some stuff related to like some physics. Unit, when you see unit in anything in math, unit means one. In this case, radius 1. So unit circle is a circle of radius 1. So S equals R theta turns into S equals 1 theta or S equals theta. And if I make a circle real quick, Davis was doing this before you guys walked in. And I go out some distance like that, this is a 1. You can make a triangle by dropping a line to the x-axis. So this distance is a distance x. This distance is a distance y. And sine theta is normally, is always for a right triangle opposite over hypotenuse. That's our theta right there. In a normal triangle, this is y over r, so you get y equals r sine theta. But in a unit circle, this is 1. So y equals sine theta. And cosine theta is adjacent over hypotenuse, which is x over r. So x equals r cosine theta. But again, r equals 1. That's a 1 there. X equals cosine theta. So this coordinate here, which is xy, is also for a unit circle cosine theta sine theta. Which takes us back to our unit circle page. Now we can fill in the rest. These should all be in the form cosine theta sine theta. And remember, these are also xy. So for some of these, it's easier to just look at what the xy are, especially since we know this is a distance of 1. This has got to be 1, 0, and this has got to be 0, 1. Those are easy to fill in without looking at sine theta and cosine theta. This is -1, 0, and this is 0, -1. Now, if you remember the table, sine 30 or sine pi over 6 is 1/2. And that's root 2 over 2, and that's root 3 over 2. over 30, 45, and 60, and cosine goes the other way. Cosine has the 1/2 up here. And goes the other way, making bigger numbers on top. Once you have those in, you can use what you learned with the whole symmetry, just do the other side, just fill them in without calculating stuff. You have those memorized. On the left side, x is negative. And on the bottom side, y is negative. So we're going to use that to just change signs accordingly. Reflect it across. Over here, x is negative, so all the red numbers turn negative. I've got negative 1/2, negative root 2 over 2, negative root 3 over 2. And I'll fill in the sine theta. We keep going, we reflect across this way. Down here, they're both negative. So if I go use this is the same thing as doing the reference angle. I'm going to have negative 3 or negative root 3 over 2 here. And that'll be negative 1/2 here. On the 45-degree angles or the pi over 4 angles, they're both root 2 over 2, in this case, both negative. And here we got the negative 1/2 and the negative root 3 over 2. And if we come down here, we're reflecting across this, but y is negative now. So my x values will just stay the same. And my y values are going to go negative. So negative 1/2, negative root 2 over 2, and negative root 3 over 2. Memorizing this is going to make everything so much easier throughout all of the rest of mathematics for you. That this blank circle is part of your first test. It's the calculator free portion of your test. I will give it out. When you're done with it, you'll turn it in, grab the test that you can use the calculator on. But before that, let's fill this circle out. There is on Canvas, I have it in the modules, a blank one if you wanna print it out or do it on a tablet. Just practice filling it out. You can get this down to under 5 minutes easily. Without a whole lot of practice, believe it or not, 4 or 5 tries, you're down to really quickly. Okay. If it helps you. Going crazy. I'm gonna put a link up here to this Calc workshop thing, and I'll even tell you where to start it.
Everything that you need is on.
She's gonna walk you through.
We also remember
how to fill
that we
all
can
this
find these
pretty quickly, just
values. But before we actually put these,
it's about a 15-minute thing, which we don't have time for here, but I will post in the module if you want a left hand. It's like a cheat method, basically. Use your left hand to fill it out. It's kind of neat. I don't know who the fuck came up with it. But you use the idea is you use your middle finger as the or not your middle finger, wherever the comma is. that's where you do this, so like on the 30-degree mark, this is the comma. I've got 3 on top here and 1 here. I'm not showing on the screen. You all like trying to look at my fucking hand. What the hell are you doing? So if you put your hand over it, like the 45-degree mark is here. X is this part, Y is this part, so 2 on top, 2 on top. At the 60-degree mark, my comma is there, it goes where it is on the circle. The top X is gonna have a 1 on top, Y is gonna have a 3 on top. 1 on top, 3 on top. Pretty fucking hack. I don't know who the hell came up with this shit. You do have to do the symmetry for the rest of it. And she talks about doing the top is 1 number lower, top is 1 number higher. She relates it to something else, but she says the same things. There is a little more in this section though that we need to cover. It's linear and angular.
Professor
What?
Jones, there's a game on Math Warehouse .com, and it's you can fill out the unit circle right there.
Send me a link to it.
Yes.
Email it to me. I'll share it with everybody. If you wanna make a game out of it, hey, if you could fucking gamify learning, that makes learning more fun. That's why they do it with like arithmetic and shit like that for kids. Like kids do not wanna sit down, and learn math or learn reading and shit like that. But you make a little game, it gets a little bit better. Alright, so more that we have in this section is linear and angular speed. Suppose we have that winch again. We've got a radius R. And we're starting at P1. And it rotates to P2. Maybe I'll make it over here. So it doesn't look like it's 45 or 90 degrees. Rotates to P2. Let's say it rotates at a constant speed. It's not speeding up or slowing down. How quickly is P1 moving? Or how, like, let's say there's something there. How quickly is an ant on P1? As the winch rotates? We're just gonna do it generically right here with no numbers, just to get the idea of what's going on. We know speed in terms of a car, miles per hour. Speed is miles, distance over hour time. Speed is distance over time. And the distance this thing is traveling is S. Over T. And we use the letter V for speed. V is for velocity, but velocity and speed are very related. Velocity is speed with a direction. That's called the linear speed. V equals S over T. Arc length over time. How fast is it rotating? rotation speed. We call this angular speed. It's like, how quickly is the angle getting larger? The easiest way of looking at this is treating it's damn near the same equation. Almost the same equation. As linear speed. But we're gonna use R equals 1. So S over T is R theta over T, which becomes theta over T. Because we're not caring about the radius. It's not related to it. So this is like theta radians over T time units. Whether it's in minutes or seconds. And we use this symbol here. It's a crazy looking W. It almost looks like artistic butt. But it's called omega. It is not the letter W. And that is angular speed. So angular speed is omega equals theta over T. I just make a W and curl the tops in. That's kind of what you're doing. Make it rounding, no corners on it, and you curl the tops in. So how do these relate? B equals S over T, which is R times theta over T. Which is R times, I'll put theta over T like that. So R omega. B equals R omega. Converts angular speed to linear speed. So the three equations, other than the unit circle. For 6.2, the three equations you need to know is linear speed is B equals S over T. Angular speed is omega equals theta over T. And conversion between the two, B equals R omega. Those are the three main equations you need for this section. That are new. Like we already had S equals R theta and shit like that. This is helpful because a lot of times when we have like a winch or something like that on a motor, it tells us revolutions or rotations per minute. So we can figure out like how much it's fucking letting out. Like how much cable is letting out. And how quickly the cable is being let out. Let's do some examples. Let's say we have a circle with a radius 15 inches. And the angular speed is pi over 12 radians per second. Our first question will be find the angle generated by a point P on the edge of the circle. After 10 seconds. So like, how far has that gone out? We have three equations. We gotta figure out which ones we have information for. They gave us angular speed, which is omega. Two of those have omega. We're looking for angle, so we want theta. The equation that has both theta and angular speed is the angular speed one. So we're gonna go off of omega equals theta over t. Omega is pi over 12. That equals theta. Our t is 10 seconds. So theta, you just multiply both sides by 10 seconds. Theta equals pi radians times 10 seconds over 12 seconds. Theta equals 5 pi over 6 radians. And this is crucial. If you want it in degrees, the angle is in degrees. The answer must show the degree symbol. Any number without a degree symbol is assumed to be radians. Two more questions here. How far did point P move? So we're looking for an arc length, right? We want the arc length, which means we want S. S equals our theta. And we have those. Radius was given as 15, and we just calculated theta. 15 inches times 5 pi over 6. Let's see, that's 5 times 3 for the inches, times 5 pi over 6. 6 is 2 times 3. The 3's will cancel and I'm left with 25 pi over 2 inches. And that's useless, so we'll throw that in a calculator and we get 39.27 inches. And I should probably only use 2 decimal places here, but that way. And if we want the linear speed. Is 3.927 inches per second. And that's it for today. We got one more example to do in 6.2. We'll do that on Wednesday. With 6.3. Have a good day, GTFO.